So I'm assuming you're still seeing my screen here. Yes, I'm still, oh, did I present anything? Did I not present any of that? Did you guys see my PowerPoint at all? No, I talked and nobody told me? Thanks, guys. Okay. Well, we'll see it tomorrow. I'll put it up again tomorrow. How's that? Okay. There was a PowerPoint. Yes, there was. I did all of this work. You want to see the PowerPoint? You want to see my proof? Look, there it is, nice and pretty. Took all this time. All right, let me just show you real quick since you missed it. There's the PowerSchool page is there. I showed all of that. I was clicking through it. I thought I had, that's great. So there's all plenty of stuff for you. I talked about all of it. I just didn't point to any of it. It's on the recording though. It should be, I shared my screen there. So, all right, let's do our calculus. Because I'm much better at that apparently than presenting, okay? All right, let's see what we're saying here. Okay, so now we're seeing it. All right, so we're gonna do 2018 number 5 and 2017 number 3, okay? So let me flip this around and we will get going. Okay, no, close. Okay, so I'm reading from my paper. It says, let f be the function defined by f of x equals e to the x times cosine x. I see that and I'm thinking there's got to be some kind of product rule coming somewhere. Because I've got a variable times a variable, okay? So somewhere I'm thinking there's probably a product rule. Or, yeah, I believe maybe a product rule. Find the average rate of change. So when I see those words, average rate of change, I automatically know I am doing the slope. But that is slope by the slope formula, not by the derivative, okay? So slope by the slope formula. All right, so here we go. Finding my a. So I'm going to find, what that really means is I'm going to find f of pi minus f of 0 over pi minus 0. You don't necessarily have to write that, but I noticed some people are liking the structure of that, so I'm going to start writing it from now on, okay? All right. Then we've got the pi. We're plugging that into this guy right here. So we've got e to the pi times cosine of pi minus e to the 0 times cosine of 0. And then 0 minus pi is just pi. All right, I'm getting out my good old unit circle. So we're out 1 up 0, out -1 up 0. I'm going to probably need these guys too. I might as well write them down because this problem has a lot of trig in it. Haven't done a lot of trig in a while. Okay, so I'm looking at the cosine of pi. Cosine is the x value, so I know that's -1. So -1 times e to the pi is negative e to the pi. Cosine of 0 is just 1, and e to the 0 is 1. So 1 times 1 is 1, and the minus comes from right there. So there is my average rate of change. I could have, the one place you can't just leave it, I'm pretty sure you do have to, I haven't seen them really talk about this, that you do have to do that evaluation on the trig. So make sure you do that, okay? It's probably safer than not. Points on that part is 1. You get a point for the answer. It's exciting to see average rate of change, but we don't get a whole lot of points for that. All right, slope of the tangent line is my next problem. So there's my function again. Slope of the tangent line at x equals 3 pi over 2. Okay, so I don't need the entire tangent line. I just need the slope. Okay, all right. So in this case now I take f prime. Okay. Oh, we thought about product rule, right? So look, I've got the product rule. All right. So I've got my red function, and I know I keep going back to this, but this is the way you guys know it. Okay, my red function and my green function. They did say something about blue or black ink and a pencil. Okay, and they said number 2. I don't know if mechanical pick up if they'll really be able to tell, but they're fixated on that. So Cameron, no markers. Okay, so blue, black ink, pencil. Okay, all right. So e is, so we're going to take the derivative of the first, e to the x, and then keep the second the way it is, or sorry, the green the way it is, plus I'm kind of falling into BC there. Oh, not that, we need a minus sign. All right, minus, And then we keep the red one the way it is, e to the x, and we take the derivative of the green, which derivative of cosine is negative sine of x. And then we take the, what am I doing? I'm doing the quotient rule, and I should be doing the product rule. That should be a plus sign, but we're good. I got the derivatives right. I just was trying to do a denominator. All right. Then to get the slope of that tangent line, we need to go ahead and plug in. Did I do that right? Yes. Okay. We need to plug in the 3 pi over 2. So, and I really probably should have said x there. So f prime of 3 pi over 2. Here you do need to make sure you tell them what you were plugging in. So e to the 3 pi over 2 cosine of 3 pi over 2 plus negative e, I guess I could have just done minus 3 pi over 2 times sine of 3 pi over 2. All right, cosine of 3 pi over 2. I did my little unit circle over here. Cosine of 3 pi over 2 is 0. So guess what? This term here goes away because it's 0. And then sine of 3 pi over 2 is negative 1. So I know that it is negative e to the 3 pi over 2 times negative 1, which is just e to the 3 pi over 2. Done. Okay, you could have probably gotten your point up in that line there. All right. So the points on this part are 1 from the derivative, so you get 1 point here, and you get 1 point for the answer. Okay. Everybody good? Okay. Let's take a look at any questions. I don't want to miss any questions here. I don't know when you asked the question, Maddie. Was it on the first one? You have to on this. Which one, Maddie? Here. I think you have to evaluate the sine and the cosine. So I think you have to go here. Does that make sense? Okay. All right. Just use fine point. They'll never know. No blue markers. Please use a pen or a pencil. Okay. All right. All right. Plus, the other thing, not just Cameron. There's a page limit of how many you can turn in. So you have to keep it in that page limit. So a marker is going to take up more space. Okay. Lorenzo, yes, I would evaluate the trig functions. Okay. I know a lot of stuff we just plug in, but trig functions, they're probably going to want to see evaluated. Okay. I really haven't noticed them doing a ton of trig in the ones from AP Live, so I haven't seen. Maybe I'll ask the Facebook group and see. Okay. No, the limit is not 2 pages. I think it's for the pictures, you're allowed to submit up to 5 pictures. So I think it depends on the test too, but I know you're allowed to submit 5 pictures, Natalie. Okay. Let's look at part C. Find the absolute minimum value, and it says the word value in it. Oh, I'm using the orange. I don't want to use the orange. Okay. We want to use the absolute minimum value, and that means that you are looking for the y, okay, at the very end. When we see that word absolute, we know that we are doing critical numbers, and we got to find the, and we got to do a t-chart, okay? So this is not a sign chart. I think it's either 5 or 10. I don't know if it's 5 per upload or 5 total. Okay, so I'll have to look into that and answer that question, Lorenzo. All right, so I know I got to get critical numbers, which means I need to set my derivative equal to 0. But there's good news. We did our derivative up here, so I don't have to do that again. So I'm just going to borrow this derivative from up there. Okay, so I know that f prime of x equals e to the x cosine x minus e to the x sine x. I know I've got to set that equal to 0 to get my critical points. I'm going to factor a little bit. I'm going to get rid of this e to the x because I just, frankly, in this one, it's just too much. I don't like it. And the good news is I could take this and I could probably put that over to the other side and divide by it. It would make it go away. So I'm really looking for cosine x minus sine x equals 0. Probably what I should really be doing is zero product property. Even if I did that, if I got it down to that in a zero product property situation, I'd have the natural log of both sides, and we can't do natural log of 0, so it becomes extraneous whatever we do with it. So here we're looking for figuring out what x is. So what I know from this is that I need to know the radian measures where the sine and the cosine are the same. And they did tell us that they actually gave us an interval here. They said it's between 0 and 2 pi. So we know that there's 2 places where they're exactly the same, meaning the x and the y coordinate are the same, including the sine. So we know the first one is at pi over 4, right? This quadrant, we know the pi over 4 is, this only happens on the pi over 4s because it's square root of 2 over 2, square root of 2 over 2. The other place where the sine and the cosine both have the same sign is in quadrant 3. And that one is this would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Okay, so those are our critical numbers. And I'm going to use a t-chart. I'm kind of, I don't know, I apparently did not give myself enough space. So I'm going to plug into my function here. So I've got x and f of x. So remember, you have to include your endpoints in this t-chart. So 0 and 2 pi. And then I've got pi over 4 and 5 pi over 4 is some values I need to put in. These need to go back into the original function, okay, not into your derivative. So I'm plugging this into my original. So I've got e to the 0 cosine of 0. Well, e to the 0 is 1. And we know that cosine of 0 is also 1, so this is 1. And again, that's good old unit circle, right? Cosine of 0. All right, then I've got e to the pi over 4 cosine of pi over 4. All right, well, I know that cosine of pi over 4 is square root of 2 over 2. So e to the pi over 4 times square root of 2 over 2. Now I've got, this is fun, isn't it? E to the 5 pi over 4 cosine of 5 pi over 4. Well, cosine of 5 pi over 4 is negative square root of 2 over 2. So e to the 5 pi over 4 times negative square root of 2 over 2. And then 2 pi. E to the 2 pi cosine of 2 pi. I know cosine of 2 pi is 1, so I just get e to the 2 pi. These are great numbers without a calculator, okay? Because technically, had this been any other year, this would have been a non-calculator problem. Let's go back and read what they actually are wanting me to find. So I am looking back in my problem, and it says we need the absolute minimum. That's good news, because I don't know in my head what e to the pi over 4 is, or e to the 2 pi is even. But I do notice that there's only one that is negative. So that one right there has to be your absolute min. Okay? So I probably need to write that down. So we would want to say something like, therefore, the absolute min on the interval from 0 to 2 pi is, and remember, it's the absolute minimum, and it said the word value, so I want the y, so I actually need this, not the x, so you need to really watch what it's saying. It's not wrong to put them both, but you need to be explicit about that, okay? So on the interval at x equals is whatever, okay? E to the 5 pi over 4 times the negative square root of 2 over 2. Done. Points. Okay? So points on this part are setting the derivative equal to 0. So you got a point up there. You got a point for identifying these two candidates. And then you get a point for this answer plus the justification table. So that's your third point on that. All right. Let's look at part 3, or part D. Part D, not part 3. Okay. All right. Oh, good. Look. We've got a graphical stem. Awesome. Okay. Here we go. I love the graphical stem. I've now got a prop. We're going to hang it in my classroom from now on. So you'll know. And and then the Algebra 2 Trig kids will go, what on earth is that? Okay. And not plus minus. Are we okay? Is absolute min? No, it's fine. I think everything's good. So then, well, at least the Algebra 2 kids will stare at it for 2 years, and then I'll finally bring it out at the end when we're looking for the test. And they'll finally understand what it is. So don't tell them what it is. Okay. Looking at part D. Let g be a differentiable function such that g of pi over 2 equals 0. So we know we're differentiable. We know we've got g of pi over 2 equals 0. They gave us the graph of g prime. So this is the graph of g prime. Okay. And we got to find the value of the limit as x approaches pi over 2 of f of x over g of x, or state that it does not exist. Justify your answer. So it's highly likely that they're aiming for L'Hopital's rule, okay? Especially because this was a 2018, that was one of the newer things that came into the curriculum for AB that year. But either way it goes, it's safest to evaluate the numerator limit and the denominator limit separately, because if you are heading into L'Hopital's rule, we are not allowed to write 0 equals 0 over 0. That's an invalid thing, and you will not get your credit if you write that down, okay? So we're going to try to write it properly. So I'm going to split those two limits up, and the limit as x approaches pi over 2 of f of x, and I'm going to do the limit as x approaches pi over 2 of g of x. And there's one other thing I probably need to add in there. Oh, no, I'm good. Yeah, we're good. So far, so good. So I'm going to evaluate the limit of f of x. So looking at that, it looks like I can just plug right into this guy right here. So we have that e to the pi over 2 times cosine of pi over 2. Well, if we got back out our unit circle, I don't even have it there anymore. Let's just do cosine of pi over 2. So we're out 1, up 0. Well, cosine of pi over 2 is 0. Looks like the numerator turned out to be 0. Okay. G. Interesting. They didn't give me a function for g, but they gave me a graph of g prime. So I have to use that graph of g prime and some of these other facts about g in order to deal with g. Okay. One thing that was super important, since that's the graph of g prime, I have to be able, in order to be able to understand that graph, I need to know that it's differentiable. And really, because that implies that it's continuous, and I need it to be continuous in order to take a limit. Okay. So I'm going to write that down above here. So because I need to show the reader that I understand that. So g is differentiable, which implies, or I'm just going to use the arrow, g is continuous. Okay. So now I'm going to try to find that limit of pi over 2. Okay. And the good news is when I plug in, so I'm just going to plug in, just like I did on the others, g of pi over 2. And I was racking my brain this morning. I'm like, I don't know where this is. I'm going to go find a video. And then in the video, I felt like an idiot because guess what? They gave it to me right there. They told me it was 0. Okay. So basically it was that because this is given. It was given to us. All right, so we have shown now that we have to use L'Hopital's rule because we really have a 0 over 0 situation. So I haven't really done anything yet. I haven't found the limit because I have to apply L'Hopital's rule. You don't need to write the LH thing. Everybody does it, okay? But it's not a required part of the points to show that you're using L'Hopital. By doing your derivative of the top and derivative of the bottom, you will have shown that. All right, so I'm going to do the derivative of the top, derivative of the bottom. Derivative of f of x is f prime of x. G of x is g prime of x. All right, I'm going to use direct substitution in. So f prime of pi over 2 over g prime of pi over 2. All right, f prime of pi over 2. Well, this is a very rare occasion that they keep connecting back to each other. We know what f prime of pi over 2 is. Well, we know what f prime is, at least. We've calculated that a few times in the problem. So I'm going to plug into that function right there. Okay. So I have e to the pi over 2 cosine of pi over 2 minus e to the pi over 2 sine of pi over 2. Andy, we're almost ready for your joke. Okay, all over. Okay, now we need to know what g prime of pi over 2 is. Well, I can read that directly off this graph. So we've got g prime of pi over 2 is 2. All right, I do need to evaluate the trig pieces. Okay, so I know that the cosine of pi over 2, we already said that, is 0. So that means this times this is 0. Minus the sine of pi over 2 is 1. So that's just a 1 right there. So we got 1 times e of pi over 2 is e of pi over 2 all over 2. You can stop there. That's going to get you the point. I probably wouldn't write it any further, but I know some of us needed a little cleaner. So that would be my final answer. My points on that. Where's your brother? Oh, did he hear me? You had to state that g was continuous. That was actually a point as part of that. And that the limit and the limits equal 0. So you had to show all of this work right in here. Okay. You had to apply L'Hopital's rule. So this was 1 point here for applying L'Hopital. And you had 1 point for your answer. But then there was a catch on this. If no limit notation attached to a ratio of derivatives. So if you didn't do this part right here, or if you missed the limit notation on this, it looks like you only got 1 out of the 3 points. It was either here or here. So you need to make sure you keep your limit notation on there. Okay? All right. Any questions on that one before I bring the joke man in? Buzz is ready to tell jokes. Andy, joke time! This year, absolutely. But in past years, no. So yes, you can have it. You can have notes out. You can have, so we're going to probably next week, we're going to try to kind of come up with of what you should really have out in front of you to how to set up your test environment. Okay. But yes, definitely. I would take that first, find your calculus book. That first inside page of the calculus book has all the derivatives and the other side has all the trig. So that might not be a bad reference. Okay. The alien is back. And messy. All right, there's no joke today?
I have a joke. I have a couple.
All right. Well, Ellie's got a couple of jokes she's going to tell. I'll get the alien here for everyone who hasn't seen the alien. He tattled in.
Jokes!
Okay, quick, jokes, because we're running late today. Okay, go for it. Tell the joke.
What's a cow's favorite kind of math?
What's a cow's favorite kind of math, Ellie?
Calculus.
Calculus. Oh, boy.
Sorry.
Uh-oh, Maribel says, why did the pony get sent to his room?
I don't know why.
Well, I don't know, Maribel, why? I don't know what I want to call a cow with 3 legs, Nathaniel. He wouldn't stop horsing around. Okay, Andy, joke.
Where does Ham go to school?
Where does Ham go to school?
Oh my gosh, this one's so messed up.
I don't know, Andy. Where does Ham go to school?
Hogwarts.
Hogwarts. All right. Did you have another one about Woody?
No.
You didn't?
No.
I thought you had a good one about Woody. Okay. You can see it's a lot of fun at my house. All right, everybody out.
You get out, Mikey.
All
Get
right.
out.
Daddy, I need help. Okay, wave goodbye. He's not in his Woody outfit yet. You got to go get your Woody outfit on so you can join the Toy Story Party Club. Okay? All right. I know. You just got to. Okay. We'll move on to some calculus now. All right? And we'll come back for a Kahoot in a few minutes. All right. Here we go. Oh, good news. Ellie, wave that graphical stem again, please.
What do you think I'm doing?
I know. We're going to do a whole problem that has a graphical stem. Awesome. Okay. I gotta do this really quick. Okay. Shh. I know. Okay, you gotta be quiet right now, okay? All right. So we are going to work on number 2017, number 3 now. Okay? All right, so here I go. I'm going to read the problem. The function f is differentiable on the closed interval from -6 to 5 and satisfies f of -2 equals 7. The graph of f prime of the derivative of f consists of a semicircle and 3 line segments as shown in the figure above. We should be getting really good at these. We've seen a ton of them. Find the values of f of 6 and f of 5. So I'm going to start by finding f, orange, don't want orange. F of -6, okay? Oh, good, shut the door. All right, so we have to remember you always start with your initial condition. This is where you start. You have to include it in everything. So I know I have to start with f of -2. And then I'm going to add that to, remember, this is the x part, the lower part of your bound, -2. This is the end part of your bound. Okay, I need you guys to be quiet.
He's doing his job.
I understand that, but I need you to be quiet. Okay?
Yeah, Davey.
Ellie? Okay. And then we've got f of x dx. Okay? So, not f of x, f prime of x dx. All right, here we go. So I know that this thing here, this f of -2 equals 7. I don't like the order that this is in because my bigger number's on the bottom, so I've got to flip it from -6 to -2 of f prime of x dx. All right, so -6 to -2 is the area of that triangle. It's never quiet at this house, ever. That's why I get up at 4 in the morning, so I can have peace. 1, 2, 3, 4. So 1/2 the base of 4 times the height of 2. That was a horrible height of 2. All right, totally stop there. Okay. If you really must have the answer, because I know some of you must have the answer, it ends up being 3. Okay. All right, we are not done though because there was another part to it. Okay, so we also had to find f of 5. So again, I'm starting in the same place I did before. I always have to include that. So I really need f of -2 plus the integral starting at -2 all the way until 5 of f prime of x. And I know that I totally didn't mention the graph is f prime. All right, so I know that the f of -2 is 7. I've got to go this time from -2 all the way to 5, which means I have a half circle that is negative because it's signed area, and I have a triangle. So I'm going to do plus. I'm going to add a parentheses. You don't really have to, okay, on this particular one. So area of a semicircle would be pi times the radius, which is 2, right? 1, 2. Squared divided by 2 because it's half the circle, but you have to make it negative because it's underneath the x-axis. So that's your signed area. Plus the area of that triangle, 1/2, 1, 2, 3, times the height, 1, 2. Stop right there. Do not evaluate anymore, okay? Because you don't want to make a mistake from there, okay? If you must know, it is 10 minus 2 pi, okay? All right, points on that part. So the points on part A says that you get 1 point for using the initial condition. And I'm going to guess that you have to use it in both places probably to get that point. Super important though. And then you get 1 point for this evaluation and 1 point for this evaluation. What on earth is going on in the chat? All right. I don't know what Madison said. All right. I don't know. Or maybe it was her face that she was making faces. Okay. I don't know. I lost it apparently. All right. There's a lot of screaming here. Part B. On what intervals is f increasing? Justify your answer. Okay, so that one means we need to do a sign chart because it's just asking increasing. So we need to do our good old sign chart. So I'm going to pull that out. We need to know where the critical numbers are, so we can find f prime zeros. So my zeros look like they're at -2. Looks like that did not get pasted well. And 2. And then 2, 3, 4, 5, which is also an endpoint. Okay. My other endpoint was -6. So -6, -2, draw my fence, 2, and my other endpoint 5. And I'm always looking when I do this part of the assigned chart if I am above or below the axis. So if I'm starting from -6 to -2, I am above, so it's positive. From -2 to 2, I'm below, so it's negative. And then from 2 to 5, I'm above, so it's positive. And again, we were supposed to be finding intervals where it was increasing. Okay, so the two intervals where it's increasing are here and here. So again, you should have your sentence frames written out. Natalie made a comment about you, Madison. Read the chat. All right. So I'm going to write that sentence frame. You should probably have those sentence frames written out kind of on a page next to you so you can always refer to them during the test. So my sentence, F is increasing on, and so this one's a little bit crazy, okay? Yeah, up until this point, they've always said open intervals, but I was looking at the scoring guide on this one and going, oh my goodness, there's something crazy that happened. They use closed intervals on this one, okay? So if it doesn't say open intervals, and this doesn't happen very often, it almost always says open intervals, you can go ahead and use those brackets. So I'm going to use them today. I know we don't normally, but I'm going to use them, okay? Typically, it's not this way though. -6 to -2, and from 2 to 5. All right, and then because we have to tell them why, f prime is positive on these intervals. Okay. My mother-in-law always knows right when I am teaching, apparently. Okay, we good on that part? Any questions up to this point? So how do we know if open or closed? Oh my goodness! A messy alien has arrived. Okay, can you be quiet? Uh-oh. The babysitter has arrived too. You gonna go with Ellie or are you gonna stay and be quiet?
Stay and be quiet.
Okay. All right. Take him. Okay.
Okay.
So I would say make them open unless it should say open intervals. I would make them open for the most part. This is the only reason I didn't is because it didn't say open intervals in the question step. Okay. Are there any other? Yes, Michaela, you can put F. You can also, so Michaela's question is good. I wrote it one way in class. You can also write that. It means the same thing. Okay, so perfectly acceptable. Okay, lots of ways to do the same thing. All right. Yes, Maribel, you can use the union symbol instead of and. Okay, it was like I was reading your mind because you typed it twice. Okay, part C, which means we're only like 5 minutes, 7 minutes, 8 minutes away from the Kahoot, right? Because I know that's why you're really here, because you have to see Andy's commentary during the Kahoot. All right, or Buzz Lightyear today. All right, so find the absolute minimum value. Again, it's a value, which means that we are looking for the y. Okay. On the closed interval, justify your answer. Your t-chart is your justification. So that we hadn't seen one where we had both, like a sign chart, and a t-chart in the same problem. So this is kind of a different thing for us this time. So I need to go ahead and get that t-chart out. I am going to, I have to pick on my endpoints, so I know -6 and -5. There's kind of good news. It said minimum, right? So that means I already can kind of know what the minimum is. I have a candidate for the minimum here. I know that this is increasing to decreasing, so that would have to be a max. So I do not have to test -2. I only need to test +2. So I'm only going to put +2 in there. Okay, so it's kind of a nice little shortcut. So we are putting these into f of x, which I kind of, we did it, didn't we? We know what this is from part A. Go look up at part A. We actually know, and this shouldn't be +5, or should be +5, not -5. If we look at part A, we actually too far. We evaluated -6. Uh-oh. We actually needed to go all the way because we needed that number, huh? And we needed this number too, because this would be kind of ugly. So this is a scenario where I would stop here and still stop here, because then I earn those points for sure. If I need to do more calculation, do that calculation on these down in this problem, okay? Because then if I mess up the calculation somehow and I don't lose the point up here because I had an arithmetic error, okay? Lorenzo, don't write the word prime out. Only write the little mark, okay? Please don't do that, okay? I don't think they mark you wrong, but don't do that. So we know that -6, because we evaluated it before, was 3, okay? And we know that this one is 10 minus 2 pi. So all we have to do is evaluate the 2, okay? So I'm going to use that same kind of formula from before. I need my initial condition, which was 7. And then I need to integrate from the -2, which was my initial condition, all the way to 2 of f prime of x dx. Well, that means I need to go over here to my graph. I know that all I'm getting this time is my semicircle that's underneath, okay? So that means that this is 7 minus my 1, 2. So it's pi times my radius squared over 2, okay? What did I do? And I subtracted because it's underneath. I don't think I wrote my answer right, but was it 7? Did I have the right answer there? No, I did not. Okay, so I know if I simplify that a little bit, it's 7 minus 2 pi. So here's how I want to think about this, because I still need to find the minimum, and I don't have nice numbers there. And yes, you could use your calculator this year, but I think if you think about it, it's going to take longer to type those in than if you just take a couple seconds and actually look at the arithmetic that's there. So think of pi like 3. So this is like 10 minus 6, which is 4. I'm just estimating. And then this is 7 minus 6, which is 1. So obviously this one has to be the minimum because that one's smaller. So you want to say, therefore, the absolute minimum, if you want to use the word value, you can, is, or you want to say of f is 7 minus 2 pi. Done. Points. So the points on this part, you got 1 point for considering the 2, and you got a point for the actual absolute minimum value here. All right. The last one we're going to do. Oh, there's some tricks on the last one. It's not pleasant. Okay. Sorry, we're ending with an icky part. We've got f double prime of -5 and f double prime of 3. So what we have is the graph of f prime. We need to get to the graph of f double prime, which is really the slope of the slopes of this graph. So I'm going to start with the -5 slope. So I want the slope of f prime, which means really what I'm looking for, because I want the slope at, this is -6, I want the slope right here at -5. I need to figure out what that slope is. I could count it off of there. That's fine. That's legitimate. Or I could evaluate it. I'm going to go for the evaluation because we haven't practiced that in a while. I know that this point is out -2 up 0. So my y's would be 0 minus 2. My x's are -2 minus -6. So that's going to be positive. So I would end up with negative 2 over 4, which I would leave. Actually, I would leave this. Stop there. Okay. But it is negative 1/2. Now, the other one's a little trickier. Okay. Because notice it said that funny thing in there, or explain why it does not exist. Why would they put that in there if they weren't going to use it? Okay. Or you didn't have to prove it. So in order for us to have a slope or a derivative, I cannot have a corner or a cusp. And you'll notice here at 3, I have a corner. So I need to prove why I don't have a derivative at that value right there. It has to do, you're going to have to prove it with the limits, okay? So we basically need to show that the limits approaching this side or those slopes are different. They're opposite limits, okay? So here's the setup on this. And again, remember, yes, Gabby, we use the negative 2 as lower bound because it's the initial condition. Sorry, I just caught that. Don't freak out by looking at this part. If you got all the other points in this problem, you were doing fine, okay? You don't have to get every point on every problem to pass. You need to get like 40%, okay? So part A, part B, you're probably good, okay? If you want to get a 5, you need to get A, B, C, and maybe a little bit of D, okay? Maybe not even that. All right, here we go. So we've got the limit as x approaches 3 from the right side, meaning I'm going to look at this limit right here. I'm going to go ahead and do the limit calculation just so you see it. You could probably just count the slope off of there. So we're looking at f prime of 3 minus, this would be the value 2, 0, minus f prime of 2 over 3 minus 2. So the y value at f prime of 3 is 2, and at 2 is 0 over 1, so that's 2. Okay. Now I'm going to look at the right-handed limit. So limit as x approaches 3 from the right. So I'm coming at it now from this side over here. So I've got f prime of, and this was out 5 up 0. So f of prime of 5 minus f prime of 3 over 5 minus 3. So I know my denominator's 2. F prime of 5 is 0, and F prime of 3 is 2, and you'll notice that this one equals negative 1. So we just proved that my right and my left-hand limit don't match, so it can't be a continuous function, so it does not exist, okay? So we're going to look at, I'm going to write that concluding statement. So therefore, f double prime of 3, you may use the abbreviation DNE for does not exist, because the limit as x approaches 3 from the left of this weird function, they wrote this out, I'm not sure, you might just be able to say of the function 3 minus 2 does not equal the limit from the right. You might be able to just write out because the right and the left-hand limits do not equal each other. That might be acceptable. You could try it. Over 5 minus 3. Okay. Andy, Kahoot time! All right, any questions on that before I bring in the Kahoot master? They didn't hear me. Oh no. What do we do without a Kahoot? All right. Oops. All right, let me go yell at the Kahoot master again because I know he's super excited about that. I'm going to stop this video while I'm doing it because we don't need to record the Kahoot probably. All right. Buzz Lightyear, it's time. Okay.